All right, let's get through this. Here we go. Let's get through this today. Just give you a little background on what we're going to do today. You guys know how to graph the polar coordinates now. All right. Now what we're going to do is we're going to convert them to XY coordinates. I'm going to show you how to do that. All right. So you can take a polar coordinate. You'll be able to graph it on the polar grid. And now, after today, you'll be able to graph it on the XY grid when I show you how to convert it. All right. This is necessary because here's what it's all leading up to at the end of the unit. You're going to be graphing equations on here now. That's what we're all leading up to. All right. And it's not your standard lines or parabolas. We're going to have, one of those bad boys, very cute. Yep. All right. Some other stuff there. All right. But you got to be able to have the ability to take a polar coordinate and graph it on a XY grid. All right. So first thing I need you to do for part A is go ahead and graph 3 pi over 2. We should be able to do that. That'll be something on the quiz. 3 pi over 2. Where is 3 pi over 2? We'll first find out where 3 pi over 2 is. If you want to make it out of 12, what do you want to multiply by? If you want to make it out of 12, what do you multiply the 2 by? 6. So really, if you wanted to, you're trying to find out where 18 pi over 12 is here. And everyone found it. Hopefully, it'll be 1 right here. Nope. Yeah, calm down. There's 2. Okay, there it is. I want that same point, though, on the XY grid. This one's easy. Because remember at the very beginning of this unit, I said, hey, can anybody see the XY graph in the polar grid? Remember that? And I drew this. You don't have to do that right now. Just look. I drew this. This one's an easy one. What point is that on the XY grid? 0, -2. Yeah. Okay, so to convert this would be 0, -2. And then you could easily graph it on your grid below, your XY grid below. So in that rectangle I've given you guys, go ahead and graph 0, -2. That's easy, though. What if it's just hanging out in a quadrant, though? We're not going to be able to do it so easily. Go on to part B now. Part B is -8. Ooh, -8. We haven't had one that far yet. Pi over 3. Go ahead, graph that one. -8. -8. What are you thinking about? Opposite side. So first find out where pi over 3 is, which would be 4 pi over 12. Here's pi over 3. Got to go in the opposite direction. 8 units. 8. I think it goes out to 10, all of these. How's that look, guys? Did I get it? I can barely tell what's opposite on this. Looks good. Looks good. All right, now again, like I just talked about, you're going to run into a problem. I have no clue what that point is. And I'm not going to guess either. All right, I have 2 conversions to get your X and Y coordinate. Ready? And they're up at the top of the page here if you ever forget about them tomorrow. Right at the top here. This is on the quiz. Yes, sir. All right, if you want to find your X coordinate, and I hope everyone has a calculator with them. If you ever want to find the X coordinate, you take your R value and multiply by a cosine of the angle. That's how you convert your into an X coordinate. You take the R value and multiply by the cosine of the angle. So for us, ready? What's my R value in part B? -8 times the cosine of pi over 3. And if you guys are in degree mode, what would you plop in your calculator? Pi over 3. Pi over 3? Come on, hasn't been that long. 60. 60 degrees. So in your calculator, -8 cosine 60. And what do we end up with? 4 or -4? -4. All right, so my x coordinate's -4. The y coordinate now, anybody know how this is going to, or you can look at the top, but the y coordinate's going to be r sine theta. So the r value times sine. Say that again, Matt. So you can do -8 in your calculator times cosine. Hit your cosine button. And then, I don't know, if you're in degree mode, you got to put in 60. If you're in radian mode, you can put pi over 3. What mode you want to be in. Theta? Why are we finding a theta? Where are we? I know, but theta is the angle I'm going to plug in. So I'm going to do -8 sine pi over 3 now. Everyone all right here? And then I'll have you guys round. Let's go nearest hundredth for all these. All right, nearest hundredth. So what's your y coordinate? -6.9. I have 3. Okay, so this coordinate, this polar coordinate up here converted is -4, comma, -6.93. And then watch this magic. Go ahead and graph it on the XY grid I gave you. So over -4, 1, 2, 3, 4 down, 1, 2, 3, 4, 5, 6, and a little more. About the same spot as your polar one, correct? They're about in the same spot, which always should happen. Yep. So these are the two big ones for today. R cosine theta to find the x coordinate, R sine theta to find the y coordinate. I'll ask, just because I want to just see what you remember. Anybody remember anything we did pre-Regents in the first semester where the y had something to do with the sine and the x had something to do with the cosine? What? Good idea. Anybody where the x was the cosine and the y was the sine? Unit. Circle. A point on the unit circle. Okay, never mind. Moving on. Sorry. It was the unit circle. Like a point on the unit circle, the x was the cosine, the y was the sine. Okay, never mind. All right, go ahead. Sorry. 2 7 pi over 6. 2 7 pi over 6. Go ahead and graph it. And then I want to convert it into xy rectangular. It's called rectangular coordinate, xy. So 2, find out where 7 pi over 6 is. I think it's here. How'd I do at that point, huh? Nobody wants to chime in with anything today, huh? Looks good? Yeah, it does. That's correct. All right, ready? Convert it now. Convert it to rectangular coordinate, xy. So the x will be r cosine theta. That was great. Where's my theta button? R value? What's the R value in this case? 2, and you're going to do cosine 7 pi over 6. You guys that are in degree mode, we should be able to convert this pretty quick. Pi over 6 was what? 30 times 7, 210. So that's 210 if you're in degree mode. And let's keep rounding to the nearest hundredth. What's your x coordinate? Negative 1.73. And I'm hoping there's no rounding needed when you do the y coordinate, r sine theta. What do you get here? What's the y coordinate? Negative 1. Can we get these? Yes? We're getting these, and you can plot them on your XY axes now. And you shouldn't, again, that's like a nice little check. It should be in the same spot it is on the polar grid. So if you go negative 1.73, negative 1, yep, we're right around where it is on the polar grid. Questions from you guys? Yep, that was about 7 minutes right there. Here's another 7 minutes, 7.5 minutes. Whew, review of the good old days. Reference angle. You got an angle of 160. What's its reference angle? Let's review quick. Oh boy. You don't have to draw this, but 160, where am I? Second quadrant. Right, here's 160. Anybody remember where the reference angle was? Why don't you comment down back there, tough guy. Where's the yeah, it is 20, but where is it? It's formed by this side and the x-axis. Always the x, never the y. We okay on why it's 20? 180 minus 160, 20. Hey, this is how we write it. I don't know, what is that? Anybody know that Greek symbol? Is that beta? And we put we put the subscript r that tells me it's a reference angle, 20 degrees. All right, what about for 300 then? You got an angle of 300. I don't know, is it? Do we think it's 60? I don't want to go rush through this. 60? All right, smart ones. Negative 5 pi over 6. All right, real quick. Doesn't hurt to throw up a little diagram. Remember, what's pi over 6? 30 times negative 5. Negative 150. Negative 150. Where am I? Negative 150. I'm in quadrant 3. And here's the reference angle. What's that angle measure? 30, but some of you guys, hey, this is good practice for the quiz. What did I start in? Radians. So you better give me an answer in radians. So 30 degrees is the reference angle, 30 degrees, but in radians, pi over 6. Anybody want to tell me, so I don't have to do a darn diagram anymore? When you're given radians, how can you find the reference angle pretty quickly? Negative 5 pi over 6, and it was pi over 6. There you go. Whatever it's being multiplied by. So remove the 5, remove the negative, pi over 6. Okay? 78. What is going on here? Okay, how about I teach a little here? That'd be great. Where's 72? First quadrant. 72 degrees is in the first quadrant. Okay, it's 78. 78, yep. First quadrant. Reference angle is formed by this terminal side in the x-axis. It's 78. Yes, 70. It's got to be less than 90. You're correct. So if an angle's in the first quadrant, it's the reference angle. All right? Whew. That was more painful than I thought it was going to be. All right, a little challenge before we end the day together here. I'll give you the reference angle in the quadrant. What was the original angle? Okay, so this first one, the reference angle 70, but I'm in quadrant 2. So you better give me an angle between 90 and 180 as your final answer here. So ready? Let me just draw it out. Let me draw it out, kids. So here's your reference angle. It's 70, right there. 70 degrees. I need to know what the original angle was. Reference angle 70 in the second quadrant. What was my original angle? We can do a little math here, right? A little math. Nice little Wednesday. What? I'm not saying it. Yeah. So it's 110 degrees. Yeah. Pi over 3 in quadrant 3. Hey, we're not converting either. I don't care that that's 60 degrees. You're better than this. You do not have to convert. I'm in quadrant 3. Ready? So here's my reference angle. X-axis, terminal side. That angle I just made is pi over 3. And I want to know what was the full angle in quadrant 3 here. Ready? No converting. No converting. Don't go to degrees here. You don't need to. Ready? What's this over here? And we're in radians. What's this over here? That's what in radians? Pi. So to find the angle, you're going to take pi and add. Okay? So that angle is going to be pi plus pi over 3. Everyone all right what we're doing so far? You guys have done this a ton already, this unit. I don't care that they're different denominators. Yeah, hey, how you doing? Just come on, stare in next time, sure. Big circus in here, sure. Drives me nuts. Like we don't have class going on or anything. What do you got to make this if I want a denominator of 3? What goes on top if it's got to be pi? 3 pi up plus pi over 3. What's that angle? 4 pi over 3. Yep. All right, last one we can get this. Quadrant 4, reference angle of pi over 7. Go ahead and draw it if you need to. You're in quadrant 4. Reference angle with the x-axis. That's pi over 7. All right, first, think about what you need to do to find that full angle. No converting. No converting. What are you going to add, subtract together here before I start changing denominators? Yes, Matthew. Okay. 2 pi, which is all the way around. But then what do I have to take away to get to the angle I'm looking for here? Minus pi over 7. Yep. We okay there? All right. I can't take you seriously. No, I can't. I can't. But it's like It creeps me out, but on the other hand, I have a ton of respect for you because you're rocking it. And you got the guts to walk around this school, heck, even this community with that out. And shockingly, yeah. All right. Sure, there's like a parent and a kid walking down, and the parent's like, come a little closer to me there. Don't you need you drifted off to that towards that man? What do I have to change the 2 pi into? 14 pi over 7 minus pi over 7. So that angle is going to be 13 pi over 7. Yep. How'd we do with the time? Minus all the extra talking in between, about 15. All right, so again, tomorrow, you're going to work on the next couple pages and do the review for the quiz. So big work day tomorrow. Be ready. Friday